What's going on, everyone? Patrick here, welcome back, and moving on to the next problem dealing with counting. So you are selling a product and the marketing department gives you a list of 9 prospects to call. Each prospect can either reject the offer, accept the offer, or choose to have another call in 2 days. In how many ways could the prospects respond if at least 4 ask for a callback and exactly 2 reject the offer? So this here, it's going to be another labeling problem, and what's happening is there are 9 prospects we're going to have to call, and when we call each of these 9 prospects, there's going to be either one of 3 scenarios happening. They're either going to reject the offer, accept it, or choose to have another call in 2 days. So those are actually going to be the labels in the problem. So they can either reject, they can accept the offer, or they could choose to have a callback. Right? Each of these 9 prospects is going to fall into one of these categories. Now, notice we're going to have to deal with multiple cases because they're saying in how many ways could the prospects respond if at least 4 ask for a callback and exactly 2 reject the offer. Usually whenever you see at least come up, there's going to be multiple cases. So case 1, notice that exactly 2 are going to be rejecting every time. So in all the cases we go over, this column is always going to be 2. But because there's an at least 4 ask for a callback, this column is going to be changing, right? It could be 4, it could be 5, it could be 6, 7, etc., etc. And because there's a set total number of prospects, if this column is changing and this column is staying constant, that means that this column is simultaneously going to be changing with this one as well. Right? So at least 4 ask for a callback. Well, if the total is 9, notice 2 plus 4 is 6, so how many are remaining? That means 3 will accept the offer in this case. What about case 2? Well, 2, but now 5 will ask for a callback. 5 plus 2 is 7. 9 minus 7, 2 over here. Case 3, 2 would reject, 1 would accept, 6 would ask for a callback. And then finally, case 4, 2 would reject, none would accept, and 7 would ask for a callback. So there's 4 cases with this information that we were given. Notice that exactly 2 reject and at least 4 ask for a callback. So either 4, 5, 6, or 7, and then this column is changing correspondingly to this one. Notice that the sum of all of these rows is always going to be the 9 prospects. And so from here, what we can do is for each of these cases, we can count how many ways this could happen. Well, in this first case, notice that there are 9 prospects in total. And remember how I said that these are the labels? Well, if 2 reject the offer, 3 accept the offer, and then 4 ask for a callback. Right? So this here would be the total number of ways that case 1 can happen. So we set it up as a multinomial coefficient, as a labeling problem, like we've done before. Over here, it would be for case 2, 9 factorial over 2 factorial, 2 factorial, 5 factorial, like that. For case 3, 9 factorial, it's always 9 prospects, 2, 1, 6. And then finally for case 4, we'd have 9 factorial over 2 factorial, 0 factorial, and then 7 factorial. Right? So these are the expressions for the total number of ways for each of these cases. And then realigning those expressions in a row here just to see it more clearly, the corresponding numbers are these over here. And so we would just add up all of those cases to get the total number of ways that this could happen, and then the final answer would be 2,304. So that's the final answer here, and there were 4 different cases that we had to go through. Now, another way that this could be shown, another way this could be done, it's not my preferred way. My preferred way is to show it like this, with all the cases. The second way, we're also going to have to deal with cases, but we kind of split these 2 things up, these 2 pieces of information up. There's at least 4 ask for a callback and then exactly 2 reject the offer. So notice that if exactly 2 reject the offer, so if 2 reject, well, that means that 7 don't reject. And then this don't reject, that could be either they accept or there's a callback, as we know. But before getting into that portion, we just look at this portion first. So if we kind of ignore the accept and the callback, because we know exactly our two are going to reject every time, so that means 7 aren't going to reject. And so we can actually create a label there. So what we can do is we could say, out of the 9 prospects, 2 are going to reject, and then 7 aren't going to reject. And then what we would do is we would take this portion and then we'd go into detail about these 7 remaining, right? Because these 7 remaining can either accept or ask for a callback. And that's where the cases would come in, but you would only deal with those 7 now because these 2 are going to reject every single time. So we kind of took care of those 2. So that's what I meant by we split these 2 pieces of information up. We took care of those 2 here, and now in this remaining bracket, we got to see the number of ways that this 7 that don't reject can be organized. And that's where the cases come in. So notice that the first case, 4 of the 7 would ask for a callback, which means 3 would accept the offer. While these 2 are rejecting, but again, they're already taken care of. Now we're just dealing with how to organize that 7 that don't reject the offer. The next case would be from the 7 that don't reject, well, 5 can ask for a callback, which means 2 would accept the offer. Or from the 7, 6 can ask for a callback, 1 would accept the offer. Or the final case is all 7 ask for a callback and none accept the offer. And so this here, the way these 7 that didn't reject can be organized is 4 different cases. So that's another way you may see it shown. And notice that if we take this 9 factorial over 2 factorial, 7 factorial, and we distribute it in the bracket, right, just mathematically, notice that when we take this and multiply it by this, the 7 factorials will always cancel out. And so we'd end up with 9 factorial at the top and then 2 factorial multiplied by these denominators. And so we'd actually end up with that line, that same line that we had before when we did it the other way, right? And that way, personally, is the way I like to do it. It's a little bit more intuitive for me, but just in case, this is another way that solutions can show it, right? But whichever way you do it, you do come up with the same final answer.